year 11 methods, we're going to look at exercise 5F, question 8 and question 9. So these are harder function questions. So we're going to have to think outside the box slightly in order to solve these problems. So question 8 reads that we have two quadratic functions, f and g, such that f of 1 is 0, so meaning that for the quadratic f, you're going to have it passes through the point 1, 0, so it has x-intercept 1, 0. It also has a y-intercept of 0, 10. And what we also know about it is that it has a maximum value of 18. Okay, we have another function g, such that it's another quadratic. It has a x-intercept of 1, 0, and it has a y-intercept of 0, 10. And it also has a maximum value of 18. So what makes f and g different? Well, there's two different, I'm guessing there's two different possible graphs that you can have for an x-intercept of 1, 0 and a y-intercept of 0, 10 and a maximum value of 18. Now, what I first want to do is define what my quadratic is. So g of x could equal ax squared plus bx plus c, or you can write f of x equals that. Okay, ax squared plus bx plus c. Essentially, what we're trying to do, okay, we'll ignore g of x for now. We'll call it f of x equals ax squared plus bx plus c. We want to solve for the values of a, b, c, because we want to specify the quadratic. Now, the only way you can do that is on the CAS is you need to define it first. So you're going to type in ax squared plus bx plus c on the CAS. So you could go, I'll try to show the screen. I'm going to go variable ax squared plus bx plus c. Now, for some reason, the CAS doesn't like c when I define it. The reason why is, I don't know the exact reason, but it doesn't like the parameter c. So I'm using another letter to make sure it works. So I go define f of x equals that, okay? And the way you check is if you enter, so you go maths 3, f of 1, if it pops up with a value, that's great. If it doesn't, sometimes, so for example, if I change that to a c, variable, I go like that. Can you see that for some reason it doesn't like c? It doesn't like a few other letters, so you got to make sure the letter actually works for you. So I'm going to go z instead. So I'm going to redefine it. Remember, when you redefine it, it just overrides what you previously had. Okay, so that's great. So we're entering three pieces of information. So before I enter anything on the CAS, I need to take hold of what information I have. So for f, I know f of 1 equals 0. I know f of 0 equals 10. And the third point, because this gives me one equation, this gives me two equations. Because I have three variables, I need three equations. How do I get the third equation? Okay, it's something to do with the maximum value of 18. Okay, so do you remember the turning point? So maximum is a TP. So remember the formula for a turning point is x equals, the x corner of the turning point is minus b over 2a. Okay. Since it's minus b over 2a, then we know that if I substitute this into f, the function, I know the value, the corresponding y value will be 18. So your third equation, and this is I know this is very tricky, the third equation will be minus b over 2a equals 18. And what I'm going to do is I'm going to solve these simultaneously on the calculator. So that's free. What I'm going to do is I'm going to go solve for a, b, and c. Okay, so what I'm going to do now is plug it into simultaneous. So I'm going to go this button. I'm going to click it free twice because I want free equation. So I'm going to go f of 1 equals 1, oh, equals 0, sorry. Then you go f of 0 equals 10, and f of, now I'm going to use a fraction button, minus b, so go minus b, a variable, divided by 2a, equals 18. Now that's of the third equation is obviously a tricky equation. So you're solving for a, comma b, comma c. Oh, not comma c, sorry. Comma whatever we defined as comma z. Okay, we didn't use c because it didn't work. So what you notice is we've got two sets of solutions. So one is actually f of x and one is g of x. It doesn't matter which one you name what. That's why you got the reason why you've got two functions with exactly the same conditions, but how come they're labeled two different things? Because we got two different sets of solutions. Okay, so a equals negative 50, b equals 40. So your first function would be, I'm going to call it f of x, a equals negative 50. So go negative 50, negative 50 x squared plus 40b, or plus 40x, and my c value is 10 plus 10. So that's my first equation. My second equation is, scroll across, negative 2, negative 8, and 10. Negative 2, negative 8, and 10. Negative 2x squared, negative 8x, and 10. So like that. There I got my two functions. Now you could possibly do this by hand, but I'm not advising it. It's very long. Okay, it does take a while. It's not impossible, because if you know the y-intercept's 10, you can automatically sub in your c value. So you know the c value is 10, and you're just solving a simultaneous with f of 1 equals 0 and f of minus b on 2a equals 18. That's not a nice equation to solve, but if you choose to, you can do this by hand. Okay, let's have a look at question 9. Question 9, it says find a set of k values for which 3x squared minus 5x minus k is greater than 1. Okay, so we want, I'll just in red, we want this function 3x squared minus 5x minus k to be greater than 1. Now, I can't do much with the equation right now because I can't really get anything from that. What if I move the 1 to this side? So I'm going to go minus k minus 1. So we want the values for k for which the quadratic is greater than 0. So I'm assuming we want the quadratic to be above the line, the x line, okay? The y equals x line. Now the only way we can do that is, remember, we've got for our three cases, we've got above the line, no solution, touches the line once, one solution, or goes below, we've got two solutions. Okay, so we want the case where it's just no solutions. So we're going to have to use our knowledge of the discriminant. Okay, so with methods, with especially the harder questions, you're going to have to you're going to be forced to draw on knowledge that you've learnt in the past. Okay, so don't be scared of that. Just think analytically. So you want the discriminant to be less than 0. So you're going to have to find the discriminant. So discriminant equals b squared, so minus 5 squared, minus 4ac, my a is 3, and my c value is k minus 1, minus k minus 1. Okay, and you want that to be less than 0. Okay, so when you solve that, that's 25 minus 3, okay, that's minus 12, minus k minus 1, 0. I can actually take a negative 1 out as a factor. So 25 plus 12, k plus 1 is less than 0. Let's solve this. So we can go 12, k plus 1 less than 0. Oh no, less than 0, less than negative 25. I'll negative 25 to the other side. There you go, k plus 1 less than 25 over 12. K is less than, subtract 1 from both sides, subtract 12. So we should get negative 37 over 12. So the value for which this whole thing is greater than 1 happens to be when k is less than 37 over 12. Okay, I think the key was you need to rearrange the equation to make that equal one side equals 0 and interpret this analytically what this actually means. So you want the graph to be greater than 0. So the only way it can be greater than 0 is if we know it's a positive quadratic. So the only way it can be greater than 0 is if the graph never touches the x-axis. Okay, the only way a positive quadratic never touches the x-axis is if we have no solutions with the x-axis. Okay, well, meaning we don't intersect the x-axis. So you need to find the discriminant when the discriminant is less than 0, and then solve for the k value. Okay, show that for all k, the minimum value occurs at 5 on 6. Now, I want you to do this one by yourself. It's not impossible. All you need to do, remember how to get the minimum value. You're simply going, well, the minimum value is easy because we know the turning point is given by x equals minus b over 2a. So minus b, looking at our equation, minus b is 5. 5 divided by 3 is the 5 divided by 3 times 2. It's 5 over 6. So we've shown that the minimum value is 5 over 6. So look, these questions are tricky, but it is worthwhile as a math student to have a go at these because you know you'd want to really grow in the subject, and the only way to grow is to spend some time thinking about harder problems, and it will pay off in spades next year if you practice your abstract thinking skills. Okay, hopefully this helps.